In this last lesson in trigonometric graphs, we're going to look at something called the phase angle. Now the phase angle takes this format here where you've got the sine or cos function in a bracket with x plus or minus a number in it. We're going to try and identify these graphs and then draw them. So firstly, let's look at this idea here, y equals sine x plus 30 in a bracket, and see what happens compared to the normal sine wave. It's always good to compare things to the normal sine wave to see what's actually happening to the wave. Now if you look at this first example, when x is 30, this is a normal one, we always look at this. This is a normal graph. It peaks at 1, down to 0, down to -1 and back to 0. But it's 30, it's at 0.5. Now if you're looking at this idea then, if x is 30, really what you're saying is the sine is 60. Sine of 60 is 0.866. So when we're at 30, this number shifts along to there, if you like. Now 0, if we start from the start, if it's 0, then sine of x plus 30, that would just be the sine of 30, so that would be 0.5, so that number's shifting over to there. 30 we've already done, 0.866, so that's number shifting to there. If we're looking at 60, then the sine of 60 plus 30 is really the sine of 90, which is 1. So that number is coming into there. And when x is 90, that would be what, 120? So that number's going to there. So if you think about what's happening there, actually all the numbers are shifting to the left-hand side. They're going that way by 30, if you like. So let's look at this in more detail and try and draw it. Okay, so what I would do is I would copy the table out as we did before, and I would fill out all the details. The only thing I'm going to change here, for some reason that says 90, I'm going to change that to 30 there. So we're looking at sine of x plus 30. If you pause it, try and complete the table, and then we'll look back at it. Okay, so the answers from the table before were 0.5. You're doing, that's sine of 0 plus 30. That's just a sine of 30. This one will be the sine of 60. This will be the sine of 90, and so on. So if you've done all that, you should end up with this. Now, if you were to plot all these values on the normal grid, going up 3 boxes to 1, down 3 boxes to -1, and so on, 3 for 90, and all the way up to 360, then what you'll find is 0 is 0.5. If we roughly plot this, so that would be kind of there. 30 would be 0.866. It's now peaking here, and then 90 is 0.866. That might be over a wee bit to there. 120 is 0.5, and so on. And what you should find is your graph looks roughly like this. Now what you'll notice is that the graph is not finishing, so what we want to do is just extend that a wee bit to finish at 360, and the reality is you don't really need this bit here. You could probably just get rid of that. I wouldn't even draw it in. I've got it there, but don't even draw it in. So what's happened is the graph is actually, it used to peak at 90, it's actually shifted over here by 30 degrees. So plus 30 is moving it in that direction to the left 30 degrees. Now, a good wee thing to think about here is to put in the new values where it crosses the x-axis, and also the new values of the peaks and the troughs, if you like. So what we tend to do there is this idea. So that's happening now at 60 instead of 90. This is happening at 150. This is happening at 240 and 330. Okay, we'll also look at x minus 30, the sine of x minus 30, to see what happens there. Okay, so I'll give you a bit of time to copy the table out, and if you want to try and fill in all the values in the table, I'll do the first one for you. So if you do, like, that will be 0 minus 30. So type sine of minus 30 into your calculator. It should help out as minus 0.5. Sine of 30 minus 30, that's just the sine of 0, which is 0. Okay, I'll let you continue that. If you just pause the video. Okay, and if you've filled all those numbers in, it should look like this. So numbers we've seen before, except everything's shifted again. So if we're trying to plot this, for example, now 0 is negative 0.5, again roughly it's somewhere like there. 30 degrees is 0, so that would be maybe there. 60 degrees is 0.5 there, and 90 degrees is there, and the new peak is over here. Okay, so if we were to draw that, then roughly it should look like that. Okay, and you've probably got a line there as well. Okay, so that's what your sine wave should look like now. Now you don't need this bit at the end, I would just stop it here. Then what we see is the peak is no longer at 90, it's been shifted forwards. So a takeaway 30 is actually shifted it forwards 30. Again, marking the wee parts where it crosses the x-axis and where the peaks and the troughs are, just 30 forwards from where they were before. Okay, so this thing here, the 30 degrees is actually what's called the phase angle. I'll just put them in there. So that's what the phase angle, we say the graph is out of phase by 30 degrees, and that's what's called the phase angle. A plus 30 actually moves it back 30 degrees, and a takeaway 30 actually moves it forwards 30 degrees, which is kind of strange to think about, because you think a takeaway 30 would move it back, but it doesn't. It does it in the opposite direction. So here's a wee summary of what we've learnt so far. If you've got a number at the front of a trig function, it stretches it up and down, so that would go up to 7 and down to -7. A 2x would stretch it or squash it. In this case, squash it. It would squash it in. The period of the graph would be 180, so it would squash it into 180 degrees. If you put a number at the end, that just shifts the whole graph up or down. Every part of the graph goes up 3 or down 3, whatever way around you've got that. And finally, the phase angle shifts it left or right. A plus 30 actually shifts it to the left, and a takeaway would shift it forwards. And you can obviously change this number. It doesn't need to always be 30. It could be any number you like. If it was 10, for example, a plus 10, it would move it backwards 10 or to the left 10. And if it was takeaway 10, it would move it forwards or to the right 10. So I'm just going to finish the lesson off by trying to recognise some graphs. So these are the ones in the book. I'm going to go through them all, but I would expect you to maybe watch them and then try them again yourself when you go into the exercise. Right, so if we're trying to identify this first one, there's a couple of things to think about here. Well, I certainly can recognise a sine wave there in the red part. That's a sine wave because it starts down here and peaks up here. Now it goes up to 7 and down to -7, so that's a 7 sine x. It's been shifted though, and it normally starts there, the sine wave, so you need to really know your graph to do this. Sine wave normally your basic graphs, your basic sine and cosine wave, but it normally starts there. It's been shifted forward 60, so that's a -60. It's kind of the opposite way of thinking of that. Right, the second one here, I've got a cosine wave. I can tell the shape of that. So this is a cosine wave. It's up at 20 and down at -20, so that's 20 cos. And then again, if I'm looking at this here, it's been shifted forwards 35, so in the bracket it's going to be a -35. We really should have a wee degrees sign at the end here. I've not included it, but it should be degrees at the top, just outside the bracket. Because that's what it's been shifted forward by 35 degrees. Right, we've got 4 more to go. Again, looking at this, that looks like a sine wave. And it's 2.5 up to 2.5 and down to -2.5. So there we have it. And it's been shifted backwards by 20. It normally starts at 0, remember, backwards 20. So that would be a +20 in a wee degrees sign. Again here, that looks like a sine wave starting there. I know you look at it, you could think, oh, it's a cosine wave starting up there, but I'm thinking it's a sine wave that's been shifted back. So sine wave, and it's gone up to 12 and down to -12. So 12 sine. And it's shifted back 70, so that makes it a +70. Okay, to finish off, now this is a strange one, because when I look at it, I'm thinking it goes down and up. So that's sort of like a sine wave, but also it's a kind of upside down sine wave, so that must be negative sine. So it's 6 and -6, so that's -6 sine. And also it's been shifted forwards 15 degrees. So that will be minus 15, and a wee degree symbol here. It's quite a wee tricky one, that one. Right, last one, I'm starting up here where the dotted line is, and I'm going down and back up. That's a cosine wave. So it's 0.2 and minus 0.2, so that's just 0.2 cos. And because it's been shifted forwards 55, it's going to be a minus 55 and then a degree symbol. Okay, then the next lesson we're going to try and draw them, but that's a good starting point here.